All right, ladies and gents, we are getting ready for our next quiz here. Hardy, gonna walk you through. Hope you're watching this. All right, first two problems. This is basic add and subtract. Oh my goodness, do not multiply these out. Oh dear. One thing I am going to be looking for here, I want standard form. What does that mean? I want largest degree to least. So as I'm looking through here, I'm like, all right, so that's my only x to the fourth, that's my only x to the fourth. Watch your signs. That's my only x squared, x's, and my constant. That's it. Ready to rock and roll. Next one, I just said don't do any multiplying. Well, here I have to distribute. So make sure it gets all the way through. Get those set. And now we're just like number one. So largest degree. Okay. Right. All right. So we've got that next one set. Now we do have to start paying attention a little bit here because now we are into multiplying mode. And you have some options here as you're working your way through. You can distribute like crazy here. You could do one of these with your x. And then go back. Oh dear, that pen doesn't work. Let's try this one. Go back and distribute here. That's perfectly fine, especially if you have colors. Otherwise, you could do a box like I did before, but this one's not huge. So I'm going to distribute my x first, which just adds 1x to each of those. And then here, again, it's negative 12. Make sure the negative comes with you as you're doing all of those. Again, I look, largest degree, work my way down. Rock and roll. Okay, we're rolling. Now, number 4, you have a choice. I'm not going to do it in the way that I'm showing you could choose from. I'm a pattern guy. But if you were going to do it, I would multiply this out first. Again, outer and inner, you're going to have a middle term. And then at this point, you would do it just like number 3. Okay, that's one option. Your other option is to use the pattern. So again, the pattern would be you cube your first term. Since it's plus, we're going to have plus 3. Go down 1 degree with your first term. Again, this is like my A. This is my B. So at this first one, I do have 1b term because the exponents will always add up to 3. Since it's plus, we will plus again. 1 less degree on my A. 1 more degree on my B. And then we finish up with none of my A and 3 of my B. So again, 3, 2, 1, 0 with my X's. 0, 1, 2, 3 with my 6's. And we just got to make sure that we simplify correctly here. 6 squared is 36 times 3 is 108. And 6 cubed is 216. If I distribute that out correctly, I'll get the same thing here. Either one works, your call. All right, evaluate. Find f of negative 3. All right. So substitute the negative 3. Yeah, oops. Sorry about that. And for f, we're simplifying what's in here. Don't distribute. Don't do anything funky. So let's see. Negative 12 plus 3 is negative 9. But It's absolute value. So clean up all the stuff inside the absolute value, then work your way back. Here, equally as important that you use parentheses with your negative, or you're going to have sign issues. And as I mentioned before when we did this, order of operations, exponent before multiply. You cannot multiply these and then cube it. That does not work. So -1 cubed is -1. And -1 squared is +1. I'm just looking for a minute. I'm looking to see if I did something screwy. I did not do something screwy. Whew. See, I watched for myself for a second. I'm like, wait a minute, that's, oh no, that's -1, and that's -2. Negative times negative is positive. Yep, that's right. Okay. See, I even got to pause at times. All right, here comes our newest stuff. Okay, our function notation. Reminder that x is a label. Label, label. Do not multiply everything by x. Do not multiply everything by x. It's a label. Okay, now that we went over that, you know, a few times, now we can actually get down to business. So, f plus g of x just means I'm going to take my f function, and I'm going to add my g function to it. Hardy, there's nothing I can put together. You're right. You're done. There it is. So not bad, not bad, not bad. Next one. F times g of x. Not f of, just f times. So 4x squared times 2x plus 7. Little distributing action. Add your exponents and make sure you distribute to both terms. We're good. Notice I have not talked about domain restrictions yet, because remember, the only thing we're looking for if we have radicals, fractional exponents, or fractions in period where we have a denominator. Haven't seen any of those yet, so I haven't had to worry about it. All right, f of g. Remember, g is going back into f. Well, what does that mean? It means we're going to have f of 2x plus 7. In other words, I'm going to plug that in for x. There's my new x squared. I'm not taking a deep breath because I'm running out of breath. I'm taking a deep breath because I know what some of you are going to do. Don't do it. Don't distribute that again. Just please no. Either write it out as 2 and FOIL it, or do the pattern, which is squaring both terms, the 2 and the x. Multiply these together. 7 times 2 is 14x. Double it. Square your last term. Again, FOIL it to the side or use this pattern. Then you can take that 4 that's there and distribute it through. Almost lost my 1. Okay. Always working backwards or inside out when you're doing those. And finally, f of x divided by g of x. We chatted about this in class. Don't be that person. You cannot reduce that. You cannot cancel that. Those two terms are bonded and happy. Don't break them up. But domain restriction. 2x plus 7 can't equal 0. Now, even though that's acceptable, I would still prefer all reals not equal to 7 halves. I'll take this, or I'll take this. I'll take any of them, okay? But make sure you're showing me the domain restriction there. All right. What happens if there's a number here again, Hardy? Am I supposed to? No. No. We're plugging in the 2 for both F and G. So F of 2. Okay, so 2 squared is 4 times 4 is 16 minus 2 is 14. And 2 minus 8 is negative 6. Be careful. Minus a negative is plus. And we're off and rolling. So again, this is going to be one of those quizzes. If you know your stuff, it doesn't mean you can't pause anywhere ever. But I'm telling you, if you pause every time, you're going to get stuck. Just saying. And again, the quiz is slightly shorter than this, but not a lot. Okay. P times Q of 8. You're like, oh, Hardy, why? Just why? We even got 3 this time. All right. So P, we're going to stay. So we got P of 8 times Q of 8. Straight substitution. 3 times 8 is 24 minus 6 is 18. Oh, boy. Do a little side work here. 8 squared is 64 times 2 is 128 minus 3 is 125. Oh. I'm going to trust myself on that one. I'm pretty sure I'm right, though. Feeling pretty good about that one. Okay. Multiply, closed in dot, composition, open dot. If it's a composition with a number, okay, let me rewrite this in a little different of a way. Okay, basically here when it's a composition, negative 3 gets plugged into P first. So if I plug negative 3 into P, that'd be 3 times negative 3 is negative 9, minus 6 is negative 15, but it's the absolute value, so it's positive 15. That's my first job. Now I take Q, and I'm going to plug 15 in. So I got 2 times 15 squared minus 3. 15 squared is 225. Times 2 is 450 minus 3 is 447. So you're like, well, what's up here? These are the same thing. Those two, same idea. Plug the 2 into Q. So 2 into Q, so we're going to have T of what? 2 squared is 4 times 2 is 8 minus 3 is 5. We're doing that first, doing this first. And then now T of 5 plus 2. 25 plus 2, 27. Okay. And then one last time, inside out. You're like, Cardi, for the love, dude. Okay. So we're plugging 3a into T. Okay, so there's T. So T of 3a is 5 times 3a plus 2. 15a plus 2. Okay. Then, keep working our way through. We're going to take Q of 15a plus 2. Oh boy. Okay. 2 times 15a plus 2 squared minus 3. I don't have to say it again. At least I hope I don't have to say it again. FOIL to the side or do the pattern. Square my first term. Multiply them together. 30a. Double it. Square my last term. Distribute that 2 through. 2 times 4 is 8 minus 3 is 5. Woo! That was kind of fun. That was kind of fun. Use the graphs to answer the following. All right. F of negative 3. F of negative 3. Whoop. Negative 1. G of 1. G of 1. Uh-oh. Hardy, what do I do again? Oh, yeah. The open circle means to go straight through it. That don't count. That's the one we want. So, ooh, but be careful. It's the y value there. Be careful. Oh, Hardy, now we're multiplying. Okay. F of negative 1 is 1. So 5 times 1 over there. G of negative 3 is 1. So 5 minus 9 is negative 4. All right. Oh my gosh, we've been doing a composition with these. All right. G of negative 2 is 0. So we want F of 0. Hardy, that doesn't look like it's really going through 1. Well, let's see. What would we call that? See, I'm going to call that like a half. If you would have called that 1 because it's close, I understand. Oh my gosh. Oh my gosh. Oh my gosh. Oh my gosh. What am I doing? Hardy. G of negative 2. Oh, not that one. Right there. Okay. F of 2. That just solved a problem, probably. Yep, it did. Oh, dear. Well, that was kind of interesting. So, thanks for surviving through that. Maybe you were screaming at your screen as you were doing that. Hardy, what are you doing? That's okay. All right. Domain of g of x in interval notation. Notice something. To the left, to the right, range, down, up. Keep it simple. State the lead coefficient and degree. Find your degree first. There it is. That's the biggest degree, the biggest exponent we have. And the lead coefficient is the number in front of that. Don't go back to the beginning. They all come from one term. Just saying. Okay. Do we have an odd or an even degree? 4 is even last time I checked. Okay. State the number of real zeros. My gosh, we finally get to bust out the calculator. Okay. Type into your calculator what you have. And just to say again, it depends on the graph on what we're going to do here. Now again, real zeros, number of x-intercepts I see. Right now I see 2, but I'm sitting here going, well, but what if the graph is funky? So let's try zoom 0 just to see if we get a different look, because we might. Okay, so there's 1. We're hugging the line, and we're going back through. So it's still 2. So that's all you need on that. Let the calculator do its magic. Don't try and make it fancy. All right. We're starting to close in. Look, we're not even at 20 minutes yet. We're closing in. All right, graph this. Hardy, can I just put it in my calculator? Sure. But I mean, that's my y-intercept. My a value is negative 1. You know, that 1, 3, 5 business, yeah. 1 and over, 1, 2, 3, 2, 3. I mean, it's your call. I'm trying to save you time. So 1, 3, 5 is going to make that one go fast, but hey, if not, plug it in the calc. Domain is always infinite. We don't have to think. Range goes down forever. Up to positive 3. Use a bracket. Be careful. End behavior. There's my free squares. My left and my right. All I got to pay attention to is arrows. And hey, they're both going down to negative infinity. Let's go. Now, this one we may have to think a little bit. So on this one, well, it's x cubed. Now I'm just going to go to the calculator. I'm just going to the calculator. We haven't played around with these enough yet to get cute. Oops, I'm cute enough not to do that, though. Arrow down. Okay. Basically, I'm looking for anything that is going to fit on my graph. So 0, 2, 1, 1, negative 1, negative 1, 2, 2. I'm even going to press it a little here. 3, 11, and negative 2 way down here somewhere. Let's look at the picture. We don't have a lot of experience with cubes, so we'll get a little help here. There we go. Now, to be 100% honest, okay, I might have needed that. Well, I mean, I'm supposed to graph it. So I need it for the domain and range, left and right, up and down. End behavior, I shouldn't have needed it. Why shouldn't I have needed it, Hardy? Because x cubed and an a value of 1, which is positive, my brain should be thinking, even if I didn't have a graph, okay, it's a regular line with a positive slope. As I'm on the left, I'm going down. There it is visually. As I'm going to the right, I'm going up. Yes, I am. Telling you, people, practice makes this so easy if you just do some. Factoring. Oh, Hardy, did you really have to? I did. My sliding dividers out there. Let me give you a word of encouragement here. Oh, let me do one other thing. I said this in class. I'm putting it on Classroom, and I'm saying it here again on the video, so some of you don't come to me and go, Hardy, that's not factorable. You're right, because that was supposed to be plus 20, and I put it as minus 20. So put it as plus 20 if via any of the other means you haven't seen this yet. So plus means these are both going to be negative. So I need two numbers that multiply, get me here, let's see. No, 2, 30 and 2, 6 and 10, no. 12 and 5, ooh, 12 and 5. 12 and 5. Slide and dividers. I'm going to even have a chat with you for a minute. Oh, wait, I'm not done. Solve, Hardy, solve. I haven't forgotten you, slide and dividers. I'm still coming. But please, people, if it says solve, don't do what I just almost did and not solve. That would be terrible and horrible. Okay, slide and dividers. I'm back to you. If you are going to slide and divide, 2 heads ups. First heads up. When you get this part done, dang, Hardy, why are you going so fast? Because you're capable of doing a regular simple one of these. That is not what you are setting equal to 0. It's called slide and divide for a reason. You have to divide. If it goes in nice, great. If it doesn't, make sure the fraction is reduced. I mean, this one is, but again, just make sure. Okay, now I'm to here, I can get the rest. Please do that for me. I'm begging you. Hardy, I don't know what to do with this. Well, what if I add the 15? No. Factor. Is there anything in common? Hardy, why do you keep doing this to us? Because we're not experts yet, and we got to keep doing it until we get an expertise at it. Once we do, hey, we're golden. But we're just not quite golden yet. Okay, solve this algebraically. Factor it. Heck, if you really wanted to and needed to, you could use the quadratic formula on this to get the 2 zeros. Just saying. Positive and a negative, bigger answer is plus 12 and 5. Yes. So x equals 5, x equals negative 12. Do you have to draw a picture? No. Do I think it helps a lot? Yeah. because now you can look and go, okay, I'm testing 0 because I love testing 0. If I test 0 and it's true, there's my answer set. If I plug in 0 and it's false, there's my answer set. So 0 plus 0 is negative 60 greater than or equal to 0. Don't think so. No. So B is false. A and C are true. Now I have a picture to do this. This is not the answer. This is not the answer. This is the answer. Okay? Just saying. Told you they were coming. Exponents, let's go. No decimals. Flip it up to the top. And go. Doesn't just go to exponents, it also goes to the 6. Do not leave it like this. I need to know that you know that's not 6 times 3, that it's 6 cubed. So tell me. Oh boy. F, G, H, the 5 down below. You all get multiplied by 2. Except here, let's write this as 5 squared for the moment, because we got a couple of things to fix up. Positive exponents, leave them alone. Negative exponents, flip them. Positive exponent, leave it alone. 5 squared is 25. In the denominator, don't flip it back up. It's not negative. Under no circumstances should that bugger be being flipped. I already hear somebody in my second hour who will be nameless saying, are we done? Are we done? My answer is no. We're still back paid. Is the test going to be this long? No. Again, like 29, 30 questions. So it's a little less. Multiply your coefficients. Big numbers don't play by exponent rules or little number rules. 8 plus negative 2 is positive 6. 3 plus negative 10 is negative 7. Or you could just flip all the negative exponents at the start. That would work. But if we go this route, well, the 7th needs to flip. Otherwise, we're done. Like I said, if you flip all the negatives at the start, then you would just be subtracting exponents, and that's fine too. So either way is going to get you to where you need to go. And to start coming near a wrap, simplify and write in standard form. You must multiply by the complex conjugate. Fancy way of saying switch the sign in the middle. Not both. Not we do it for each one. No, whatever the denominator is, that's the one you're switching. And then you're foiling like a crazy person. So first, outer, inner, last. Don't forget the squared. First, outer, inner, last. I squared still equals negative 1. So this is 2 times negative 1, which means that's really negative 2. And this is negative 1. The opposite of negative 1 is positive 1. 8 minus 2 is 6. Negative times negative does not cancel. That is minus 8i. I's cancel. 4 plus 1 is 5. If all 3 of those coefficients had a number I could divide out, I would. But there's not one that goes into all 3, so I can't. But all 3. 3. Okay, I get here. Got to get my radical alone. And we square it. Oh my gosh, Hardy, you're doing this again. What am I doing again? That squared thing. Well, and I'm going to say the same advice for the 3rd time, I think, in this video. Foil it or know your pattern. Negative 6 doubled. Everything to the x squared side. minus 1x minus 6. And if you hate factoring with a passion, use the quadratic formula. But I'd hope on this one that's not going to be you. Okay, Hardy, but Hardy, they're not negative. 10 plus 6 is 16. Square root of 16 is 4. 4 plus 10 is 14. 10 plus 4 is 14. Okay, we're good. 3 plus 6 is 9. The square root of 9 is 3. 3 plus 10 is 13. 3 plus 4 is not 13. Whoop. Don't want to lose points. And to finish, solve. Leave the answer in exact. Simplified form. Hardy, can I use the calculator? I wouldn't. That's not going to be exact. Well, Hardy, I tried to factor it and I couldn't. You're right. What's your other tool? Oh, man. You're telling me I still got to know the quadratic formula? Hey, it's like duct tape. There's nothing wrong with knowing duct tape. A is 1, B is negative 8, C is negative 2. Opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Let's do this. If you want to put it in the calculator, I would put this in my calculator without the radical. So let's see, that's going to be 64 plus 8. So square root of 72 over 2. Hope we can still break down radicals at this point. And this is what I was talking about up in number 32. If you have something not under the radical, but the stuff outside that'll go in, you need to simplify. Okay, again, the quiz is slightly shorter, but you have got to be able to keep moving. If there's stuff in here that you can't keep moving with, if the only thing you have done is watch this video and go, well, I know what I'm doing now. No, Hardy knows what he's doing now. The question is, can you do it, sit down with nothing in your ear and do the same thing? If not, you need to go back and find that stuff and work on it more and be ready to go on Monday. If you run into questions, let me know. We'll see you later.